Yeah, hello everybody. Um, we are almost at the end. Maybe I will come through the topics of the lecture, and then the rest we can summarize and doing some um, tasks which look like your tasks afterwards in the exam. But anyway, we have to deal today with the neoclassical model. But before we start with this, first of all, again, the advertising block. On Tuesday, dear Gerlach will come and visit our university from the Bundesbank, talking about money, interest rates, and prices from the perspective of the Bundesbank on the European monetary policy. Okay, well, we have talked the last lecture about the so-called ASAD, aggregate supply, aggregate demand model. And we have derived heuristically the aggregate supply curve. And this increasing aggregate supply curve, please keep in mind the dependence of output on prices was that it is increasing was still derived from the assumption that we have at least some rigidities in the markets, or that we have some misspecifications in the expectations. And the AD curve we have derived from the ISLM model, especially from the money market, where we had M over P equals money demand, and now we have flexibilized the price level in order to obtain real money supply. And then we have argued if we have fully flexible prices and we, so to speak, change our view on the economy to the supply side, that then output in an economy is just only dependent on the, so to speak, framework of the technology, on the infrastructure, on the education level, on the resources, natural resources a country has, and that this determines the so-called natural output level, which is then independent, totally inelastic with respect to prices, and therefore the long run AS curve becomes vertically in the price quantity diagram. Well, and what we want to do today is to keep a closer look into this vertical aggregate supply curve, and we want in general to talk about this so-called neoclassical model. And within this neoclassical model, we, of course, then deal in general with real variables. Here you can compare this with the classical dichotomy and the quantity theory of money, Py equals mv. Oh, I have also to take the chat. And that we focus on real variables because we argue that this is why we are taking our decisions. It is not important to have €1,000. It is important to know what can I buy with €1,000. And therefore, as we have done it in the lecture, we always have to divide our nominal variables, the earnings of myself, the wages, by the price level so that I know what can I buy for it, or nominal interest rates divided by the price level in order to come to real interest rate. Well, and we assume fully functional markets, fully competitive markets, that what you have seen in many other lectures, supply demand, that in case when we are out of equilibrium, that we very fast will come to the market equilibrium. And there, hopefully, you have talked about why it is maybe a good decision that if you have fully competitive markets and totally flexible prices, that we exchange our goods on these markets, because then, due to consumer surplus and producer surplus, if we take this as a welfare measure, that market equilibrium maximizes consumer surplus plus producers surplus, and that we therefore call this an efficient allocation. With consumer surplus and producer surplus, you have already heard, hopefully. Yes, okay. And efficient, the definition of efficient, Pareto efficient, you also know. Efficient, what do we understand by efficiency or Pareto efficiency? Vilfredo Pareto was an Italian economist beginning of the 20th century, and he defined efficiency. Do you remember it, what we mean by efficiency? Oh, okay, then I will recapitulate this. Within a market, we start, yeah, with some things everybody has, and then we go to the market, and due to our preferences, we start to exchange these things. Maybe I have chairs and you have the milk, and then we start to exchange chairs with milk. And efficiency then means we are exchanging as long that we come to a situation where if we would further exchange our goods, that then due to our preferences, at least one person would not be better off. So we have a distribution then of all our resources that it is not anymore possible to change this allocation, that not some guy raises his hands and says, well, I have now 3 liters more, but 1 chair less. And due to my preferences, I say I'm not better off because of that. And there you can show in general that the market equilibrium, if it is fully functional, that the market equilibrium is an efficient allocation, that within these allocation it is not possible to change this allocation so that nobody raises his hands and say, no, the former allocation is better for me. Okay, so very important that with free trade and fully functionable markets, we come to an efficient allocation. And there you also see the difference to the Keynesian view, because the Keynesian view does not say that this is not true, but they just say, well, the prices are not that flexible that you come very fast to these efficient allocations. Yep. Yes. 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 Yeah. So if you have price rigidities, then you have a problem in order to come to these efficient allocations. Okay, then quantity theory of money. About this we have already talked. That in general we look only at the transaction motive. That in general money is just a medium of exchange. Well, the next two, this is the same as we have it in the Keynesian views. Of course, in economics, we assume that enterprises are profit maximizer and individuals are utility maximizer, and this we in a minute use in order to derive the equilibrium at the capital markets and at the labor markets. And overall, about this I have already talked. The exchange takes place at fully competitive markets, and this is then the case due to fully flexible prices. Market are, so to speak, very, very fast going to the equilibrium, or from a theoretical point of view, we assume that markets are always in equilibrium. Okay, so then when we look again at our long-term aggregate supply curve, then behind this aggregate supply is, of course, our production process. And therefore, we have to talk about how do we model production within our economy. And hopefully this you have seen also in other lectures when you have talked about production theory, maybe in your introductory courses in business administration. There it is quite often a topic, or of course also in microeconomics. Question? Mm-hmm. Yes. Yeah. Yeah. Flexible. So if we assume that we out of equilibrium, that prices are somewhere higher than the market equilibrium prices, and then we say, well, the people start to talk to each other, and then the suppliers, since they could not sell as much as they want for these prices because they do not find as much individuals with the demand for the goods for this price, they start to reduce a little bit the price. So additional demanders come to these suppliers and buy this, and that this process of lowering the price moves you into the equilibrium. Well, but this lowering process, or if you come out of equilibrium from a lower price than market prices, there we now assume that this lowering or increasing of the price level is going very fast. So the Keynesians, they do not say that this process exists, but they say, well, this process takes some time, and especially at the labor market, it takes a longer time. And therefore, because of course also in the actual situation, in reality, also the framework of our economy is over time, of course, also not stable. This changes also, and your preferences over time are changing. Therefore, also in reality, the supply and demand curves are not every time at the same location. They change also over 1, 2, 3 years. And therefore, if you have price rigidities, then you are, so to speak, almost always out of equilibrium because prices do not adjust fast enough. And this is one of the main difference between these two views. And in the neoclassical view, we assume totally flexible prices, that this process of price adjusting is very, very fast. Okay, but now let's talk about production. And there, when we have talked about GDP, we looked also at the distribution approach. So in general, we assume that we have the main production factors, capital and labor, and we also introduce a general parameter A, and this general parameter A we call technology. This is, so to speak, the framework of the economy, or even our society. And then we make two assumptions on this production function. The first two, very easy. The higher the input, the higher the output. And this means first derivative with respect to our two production factors is larger than 0. And the second assumption is that the second derivative is negative. And what does this mean? This means if we are already at a high production level and we increase the input, that this means that the additional output coming now from a higher production level is less compared to an increase of input on a lower production level. This is positive, but decreasing marginal production. And the third main assumptions on production is constant returns to scale. And this two assumptions we make, so to speak, a partial analysis. So we look only at one production factor. So holding, for example, capital constant, and then increasing labor means more output, or holding labor constant, increasing capital, then output is increasing. And constant returns to scale now means we are changing simultaneously both input factors by the same amount. And this is modeled by this parameter lambda. This is maybe, for example, lambda equals 2. Then this means we are doubling inputs. And if we are doubling inputs, then the assumption is that we can, so to speak, take out this parameter in front of our production function, lambda in front of f of k of L. So if this is also 2, then constant returns to scale, doubling inputs means doubling output. Well, of course, this is also a very strong assumption on the production process. And if we think of a single enterprise, then of course, if you are a consultant or within your enterprise, you are always looking at some production processes where you do not have this property. Because why? You really look into your specific production process, and it would be very nice that if you, when you're doubling your inputs, you would maybe obtain a threefold output. And for these processes, you're always looking. But why we make, from a macroeconomic perspective, these assumptions, I hope that you already have heard about what constant returns to scale mean, or scale effects. Yeah. Okay. So then maybe in microeconomics, you also have talked about constant returns to scale production. Why we make this assumption? Because it's a very strong assumption. Or if you think about mergers and acquisitions, why we are quite often do mergers and acquisitions. Actually, we hope putting from two companies, for example, the human resource department together, then we hope maybe we have 1.5 times of our people working in the human resource department, but we have now, if we merge two equally large enterprises, we have the double people working in my company. So that maybe we increase the efficiency level due to mergers and acquisitions. Have you talked about why we are in the long term and from a macroeconomic perspective, we introduce these assumption of constant returns to scale? Well, this is CRS in line with fully competitive markets. Because what would be profits, optimal profits in fully competitive markets? In general. What is the profit level? Yep, 0, yes. Because pi max, so pi profits is 0. Well, and in general, because why do we say that in fully competitive markets we have 0 profits? Of course, We are fully transparent. We have many, many enterprises. We have many, many individuals, demanders in our markets. And then we say, if there is still a possibility to make positive profits, then we have an incentive for other companies to also enter these markets, so that more or less our cake is divided between more and more and more enterprises, and in the end, from a theoretical point of view, we have zero profits because of this very, very high competition. So, and then we can ask, how should then look like the production function? Well, and then we come that the production function should in general exhibit constant returns to scale, because assume that your optimal profit level is not zero, but positive. If you make this assumption, what could you then do? If you have constant returns to scale, then you're doubling your input. Fully competitive means also you have to take prices as constant for you, for your optimization process, because you as a single company cannot change the prices, because otherwise all guys would go just to the neighbor enterprise due to full competition. But if you have constant returns to scale and positive profits, then doubling inputs would mean doubling costs, because wages for you in your optimization process is constant, and interest rates, the prices of capital and labor. But your revenue, P times X, will also double, because here output doubles also. The price of your output is also constant. So this means doubling inputs means double costs. This means also doubling output means also doubled revenue. But revenue minus costs is profit. If profit is a positive number, then also profits has to double. But then your assumption that profits were positive couldn't be true, because the change of doubling inputs would then double profits, and the only profit level which is in line with the assumption that it is optimal is zero, because 2 times 0 is also 0. Okay? And therefore, we make this assumption, since on the former slide, we have assumed that we have fully competitive markets. Okay, maybe you have seen some special production function already. A linear production function. This is perfect substitutes. Leontief, the other thing, perfect complements. And this is somehow in between. And if you, maybe look at some scientific paper which is dealing with production, then you maybe also find this function here, which is called constant elasticity of substitution. And this is, so to speak, the working horse if you make quantitative analysis of production processes. So just that you have seen them. But these three, hopefully, you have already seen. About perfect complements and perfect substitutes, I think we have talked in the third lecture, if you remember, when we talked about positive and normative statements. And what perfect substitutes and complements are, I think you also know. Yep. Okay, and this is somehow in between. Or if you look at it, if you take this k to alpha L to 1 minus alpha, then this is nothing else than the weighted geometric mean of the two inputs k and L. Geometric mean we have also talked a lot about when we have taken the average of growth rates. Hopefully this you have seen in statistics. So arithmetic mean x1 plus x2 times 1/2 and geometric mean x1 times x2 to the power of 1/2. So the only thing what you are doing is exchanging the plus with a multiplication sign and moving up the 1/2 at the brackets. Okay, so how does this production function looks like? Well, it is increasing if we increase inputs and decreasing marginal production. About this I have already talked. So to speak, starting here from a low level, maybe a one-person company, and then increasing employment from 1 to 2 guys. This would be the increase of our output due to an input increase of 1 person. And then if we are already, for example, at a higher level, let's say 10 persons are working in my company, increasing to 11 persons, and then you see that, okay, we have an additional output, but this additional output is lower than coming from this lower production level. So delta y2 is lower than delta y1, and therefore right banded production function. Okay, and with this assumptions, we go to our profit maximization process. Well, profits are revenue P times Y minus costs. So this is revenue and these are our costs. Well, and optimizing this just means varying our inputs so that pi is going to its maximum, and this means just taking the first derivative and setting this first derivative to 0. So I think this is not totally right here. We have to have a minus, or yep, this has to be a minus sign. Sorry for this. So prices, interest rates, and wages are constant in our optimizing process. Then taking the derivative of profits with respect to K means the first derivative of our production function with respect to K times P times A minus costs with respect to capital, leaving us with I, and these two in optimum has then to be set to 0, and this then means, okay, we obtain that marginal product equals our real wages for labor, and we also know that the second derivative is lower than 0, and therefore we know that we can take here taking the inverse function, since this is a decreasing function, then of course also the inverse function has to be also decreasing. And this then means solving this function via the inverse function for labor, we obtain also a negative dependence then for labor demand on real wages. Well, and this is what we generally expect. We will hire less people the more we have to pay them. So we obtain then L W over P is just a decreasing function, and this is then labor demand. So these properties are then just derived from our general assumptions on the production process. Or maybe in microeconomics you have seen this graphically. Well, the blue line we have already seen. This is our production function, this right-banded production function. Costs are just wages times labor. So this is our production function. And this is costs. Prices are constant, so this is just a linear line through the origin with slope of real wages. Linear line through the origin. Well, and then we have to maximize just the distance between these two functions. And where do we find the maximum distance between these two functions? Well, this is just the case when the slope of our cost function equals the slope of the production function. Because then, if we go to the right, the function is right-banded, the distance becomes lower, and on the other hand, we see the same, because then the marginal product is steeper. So, maximum distance between production and real costs we find when the slope of the production function equals the slope of the cost function. But what is the slope of the cost function? This is just real wages, and the slope of the production function is the first derivative of the production function, marginal production. So df or dy, sorry, dy with respect to L. These two has to be the same, and therefore also from a graphical analysis we obtain dy dl is a df dl equals real wages. Have you seen this diagram, maybe in macroeconomics or in production theory? Okay, and then we can ask ourselves what happens to the optimum labor level if wages are increasing. So if we increase omega, assume omega 2 larger than omega 1. Well, this is just the slope of our linear line of the cost function, so this is turning to the left. So real costs are just turning to the left. It becomes steeper due to the assumption of our production that we have a higher marginal product, that the slope of the production function is also steeper the more we go to the left, then the new optimum distance is, of course, lying at the left of the starting point depending on omega 2, omega 1. And therefore, if real wages increase from profit maximization, again, we reduce our labor demand, and again, we obtain that labor demand is a decreasing function depending on wages. Okay, so now we have labor-derived labor demand. And then, as I mentioned in the last lecture, please have a look also at the household optimum. We now want to derive the labor supply. So how much you want to work given some wage level. Well, why are you working? In order to earn money, and what to do with this money you want to consume. So then we assume that your total earnings, wages times labor times your time you are working, equals your consumption. So here we assume that you are spending your total money on consumption. So this is your earnings, and this is consumption. Well, and so to speak, this is then just your budget constraint. You cannot spend more than you earn. We fully spend our labor income on consumption. Well, fully competitive markets, we cannot do anything about the wages. Take it or leave it. But what we can do, we can choose our time we work. But there we have a second restriction. We can only work, let's say, 16 hours a day. 8 hours we sleep and 16 hours we can work every day. So we are restricted in time to work. And this time, let's say 16 hours a day, there, due to our preferences, we choose how much do we work, L, and how much spare time we have, just sitting at the beach. F, spare time. So maybe you are working 12 hours a day and sitting 4 hours at the beach. So, and now we put these two restrictions together. This means that L is L bar, so L bar total time. L bar minus spare time. And this we feed in to our budget constraint. So we obtain P C equals wage times L bar minus F. Then we divide both sides by the wage level. Then we obtain P over W, C equals L bar minus F. And then we write L bar equals one over now W over P. This is the same as this one. Okay. Taking the inverse, then we have to also take the inverse of this ratio times P plus, and now I write 1 time spare time. So, and why I do write this? Well, we assume that we have a utility function depending on consumption and spare time. And both dependence should be positive. The more spare time we have, the better we feel. The more trousers I can buy, the more I can consume, the better I feel. So consumption and spare time are my two goods. So this is then my restriction. And what I want to do then is maximize U of C and F subject to L bar equals 1 over W over P times, not P, there has to be a C, sorry. C plus 1 times F. Well, why did I do this? Well, this is nothing as real wages. W over P. Therefore, I have written this. But why do I have manipulated this problem to this one here is if we now put beneath your classical household maximization problem, which you have analyzed in microeconomics, then you find U of x1, x2, subject to m equals p1, x1 plus p2, x2. And hopefully you now see the correspondence here. What do we have? P1 is 1 over real wages. P2 is just 1. And your budget is your, so to speak, time budget. X1 is C and X2 is F. So now we have a 100% correspondence between your household optimum and this maximization or this consumption spare time problem. So, and now hopefully you remember what you have done in microeconomics. I think you have started with your budget line. So here we have F. What is the maximum amount we can have for spare time, for free time? Therefore F. This is if we take the full 16 hours, or this is one possibility. I do not say that it is optimal, but this is a possibility. So we obtain here L bar. What is the maximum consumption level? Well, if we are fully working, so if we are off work, L bar, the full 16 hours, this is spent totally then for consumption. And then we find, where do we have it? Here. That we obtain for the maximum, or let's take a little bit lower here, since I will change then, that this is V over P times L bar. So in our budget restriction, setting C or F just to 0. Okay? So this is of course also a linear line. And this was your x2, x1, where you had this one m over p1 and m over p2. Where do we find the optimum? We take the indifference curve, moving the indifference curve due to our preferences as far outside as we can. So maybe somewhere here. the optimum indifference curve. So this would be then our, oops, not bar, but star, our optimum labor time level. Due to the preferences U of C and F. So what happens if wages increase in this picture? Let's take this in red. And nothing else changes. What happens in this picture? If wages increase, or we can also say, let's say real wages that we are taking this one. Yep. Then you are already at a new optimum. But at first I will want only to know what happens here in my diagram. And then we have to analyze if really consumption will be higher. Which function, which line directly changes in our diagram if real wages are increasing? Yes. And how does it change? Yeah, but your colleague, she directly said that consumption increased. This we don't know if the optimal consumption level is then higher than this one. This we don't know at this point of view. Oh yeah, okay. You meant here the cut on the vertical axis. Okay, then you're right. Okay, so this is just moving up because this number is increasing. Okay, so and now what can happen is unfortunately both things. You know, having now this new budget restriction, the optimum has just to lay somewhere on the upper right. We are moving then this indifference curve outward. And what we see now that in general, two things can happen. That maybe this one is an optimum or this one. Both after omega has increased, both points are possible optima. Well, and in one case, the optimal, oh, this one has to be F, sorry. I see here. In this case, the spare time has increased, although we earn a higher wage, And in this case, we decrease spare time. Yep. Yes, there will be, of course, if we have fully specified this function, there will be then only one point. But now we are in the situation that in general, we don't know the preferences. Yeah. So, and due to this new budget restriction and the utility maximizing process, we only know that in general, it has to be tangent again to the new budget line and somewhere on the right. But in general, we don't know if the outward the process going outward to the right will end up in this point or can also end up in this point. This is due to how actually looked like this utility function. This could be different for you. It could be this point, and for you, it could be this point. You know, preferences are totally individual. Nobody can say what kind of preference you have to have. And this is a pity because, in general, if the human resource guy in the enterprise would offer me more money, in general, we would assume that I start to work more. Since for every hour, I get more money. But the general utility maximizing process has also the possibility that although I obtain per hour now more money, I'm decreasing my labor supply. Well, and there, I think you have done this also in microeconomics. You have two different effects. You have a so-called substitution effect and an income effect. You have talked about this? And if we increase our labor supply due to a higher wage, then we assume that we have a high substitution effect, because what do we then start to do? We exchange spare time with consumption. We reduce our spare time and increase consumption, substituting these two goods. The income effect says, well, in my former optimum, I had some income. Let's say 50,000 euros per year. Then the guy of the human resource department offered me, well, you can earn now, working the same time, 55,000 euros. And then it could be possible, due to your individual preferences, that you say, well, 50,000 euros is enough for me. I do not need this additional money. I'm already happy with 50,000 euros. But if the wage has increased, what can you do then? Then you can reduce your working time so that you just still earn 50,000 euros. And this is then the income effect. So here, substitution effect is higher than the income effect. And in this case, substitution effect is lower than the income effect. Well, and in what situation we are, we don't know. It is totally individual. But, and now we make an assumption, R And we also look at the data that in general, we assume now that the substitution effect we assume is larger than the income effect. But this is an assumption we make. And why do we do this assumption? Well, we're looking at the wage distribution in the society or income distribution. And if we look at the income distribution of the society, what do we find? We find some rich people and many people around the average, and even we found a higher number of poor people than these very rich people. So these are rich people, and this one here are poor people. Well, and then we make the observation that in general, poor people in a society would in general be very happy to have a higher wage and then to increase their consumption. And if we look in general at rich people, there we say, well, these rich people, they have already that much money that they do not say, well, if you give me additional 1,000 euros, I don't care about it. And since the poor people are more than the rich people, from the macroeconomic point of view, then we can assume in general we find much more people where the substitution effect is higher than the income effect. And this then would mean that we will have an increasing labor supply function. So here, increasing labor supply with respect to real wages. Well, 1 minute left. Then, very surprisingly, we take these two derived supply and demand function together, and the cut of supply and demand is our labor market equilibrium. Okay, this take much longer time, but anyway. Maybe then I leave out the capital market. I don't know. Let's see. Okay, but then we will stop today, and Tuesday is the talk from the Bundesbank, and then the last, so to speak, lecture with the topics will be on next Thursday. Okay, thank you very much for today.